Hello everyone, I'm Hongbo Fang. Today I'm going to present our recent work. This is DAMSLIC, estimating the impact of tweets on open source project popularity and new contributors. Open source software projects nowadays are very important. Its success has been featured by those well-known projects like Linux or Apache Server. And we can see the adoption of open source software in many fields, including energy, healthcare, and environment. In 2015, a study reports 78% of companies use open source software to provide service to their customers. And in the year of 2020 alone, OSS projects contribute $59 billion to UK GDP. Open source software is an important digital infrastructure, and it has tremendous impact to our daily life. Despite its popularity, the lack of community attention and developer contribution are major threats to its stability. This is even true for those projects used by millions of people. Taking the example of curl, which is a software library installed on over 1 billion connected devices, including your cell phone and cars. However, the vast majority of its development was essentially done by one developer alone. The lack of developer contribution can cause problems like a delayed bug fix, a higher likelihood of project being abandoned, and to extreme, it can cause severe security vulnerability like the Heartbleed instance in 2014. Research has shown that developers tend to work on projects that are fun and interesting, and those fun, interesting projects tend to draw a lot of community attention. However, being fun and interesting doesn't necessarily mean they're important. For those really important projects where our government, business, and the public rely heavily on, they need better ways to promote themselves to draw community attention and recruit new developers. There are various ways developers can do to promote their projects, and our researchers have studied the effect for some of them. For example, we look at the effect of using badges to promote projects for higher popularity, or the effect of using different versions of READMEs and different ways of communication with other developers, or the effect of having an official project release on GitHub. The vast majority of studies today focus mainly on the effect of things developers can do on the code hosting platform itself. There has been a relatively lack of understanding on the effect of things developers can do outside. For example, the effect of project promotion on social media platforms like Twitter. So why do we even care about Twitter? It turns out that Twitter is widely used by open source developers for promotion purpose. Taking this tweet as an example, this person starts with a short description of a package of a GitHub project. This is a DAMSLIC node natural language processor, and it contains a link to the project homepage. The example I'm showing here is not real at all, with research shows 70% of open source developers use Twitter regularly, and among those people, 60% of them use Twitter for promotion purpose. The ubiquitous use of Twitter for OSS promotion motivates us to ask the following 3 questions. First, whether Twitter promotion on open source projects help increase the project popularity and attract new developers. Here, we only look at projects hosted on GitHub, and the project popularity is defined as the number of stars. New developers is defined as developers who never committed to the project before and made their first commit shortly after the tweet. Next, what are the factors associated with the size of the tweet impact, if any? And lastly, can we characterize the developers being attracted so that we can better know which group of people are more likely to be influenced by tweet? Because of the time limit, I will focus only on the first 2 questions in this presentation, and please read our paper for more discussion on question 3. I provide the highlight of our research. We claim causally that tweet promotion attracts more stars and developers. This claim is a hard one to make because most of our statistical tools used today deals with association and correlation. It's hard to make causal claims, especially without the involvement of experiments. So how can we shift from the association to the causal claims that we want to make in this study? Let's start with some simple regression model that many software researchers, including me, have used in our past research. It usually starts with an outcome variable. In this case, it's the number of stars or number of developers. And it has an independent variable. In this case, is the existence of tweet. We can also add some other control variables to account for the effect of other variables. Let's say after controlling for all those variables, the estimate the effect of a tweet is associated with 4 stars. However, this 4 star is not a causal relationship because we didn't take into the time of event. We didn't take the time of the event into consideration. This model is subject to simultaneity bias, which means we cannot determine if it's the tweet that causing the star to increase or it's the high number of stars that caused the tweet to be posted. To solve this problem, we can conduct a time series analysis. The key idea is for any causal relationship between 2 variables, the cause must appear before the consequence. In the example, if a star is received before the tweet, it's not likely to be a result of the tweet. But oppositely, if it's received after, it may be caused by that tweet. Assuming in the example we see before, the 4 stars associated with the tweet, 1 of them is received before the tweet and 3 after. An improved estimation of tweet causal effect is calculating the number of stars received after the tweet and subtract that by the number of stars received before. So here we get 2 stars. We get 2 stars attracted by the tweet. This model and idea is not new to our community. There has been several papers, including the ones from our group, that we use time regression discontinuity analysis, which use the same idea as time series analysis to study the effect of using badges to promote project. However, even with this improved estimation, this is still not causal enough, and there is still room for improvement because there are other confounding events that will bias our estimation for tweet causal effect. I will use this graph to illustrate the point. Here we have one project. We have the number of stars received before and after the project. While the star received after may be caused by the tweet, it may also be caused by other confounding events happened at the same time as the tweet. If that's the case, we are very likely to overestimate the effect of the tweet because we falsely attribute the stars caused by those other confounding events to the tweet promotion effect. To control for that, what we can do is to have a control group where we select another set of projects with similar project level characteristics as the projects being treated. The selection was done through propensity score matching, and we call those set of groups our control group, those set of projects our control group. Next, we get the number of stars the project received before and after the time of the tweet for the control group. Note, the control group are not really being treated. We just use the time of the tweet. The estimated causal effect of a tweet is calculated by first calculate the difference between the number of stars received before and after the time of the tweet for both the treatment group and the control group. That's our first difference. And then we calculate the difference of that difference between the treatment group and the control group. In this example, the estimated causal effect of a tweet is 1 star. The key idea of this model is that for any confounding events, as long as it applies to both the treatment group and the control group, its effect will be canceled out by conducting the second difference calculation or conducting the blue difference calculation. So what are the confounding effects that will be controlled under this framework? It could be a new feature added on GitHub, which potentially have impact on all projects hosted on GitHub. It could also be COVID, which research have shown tremendously changed the ways developers contribute and collaborate with each other. It could even be a financial crisis, which may have similar effect as COVID and change the ways developers contribute to OSS projects. Note that all those variables are not easily controlled for if we add control variables for each one of them. But we can control for all of those effects by using this control group design. Lastly, there's still one group of confounding events we haven't controlled, which are those events that are more likely to apply to treatment group. For example, for a project being tweeted or promoted on Twitter at a given time, at the same time, it's also more likely to be promoted on Hacker News, on Stack Overflow, and also it's more likely to have major in-project event like official project release than other projects that are not being tweeted. There were so many such confounding events that we have to control for them as much as possible. So what we did in this study is we explicitly control for two of those events, two events that happened on GitHub, which are the formal official release of that project on GitHub at the same time as the tweet, and the project appearing on GitHub trending page at the same time as the tweet. To control for all other social media discussion and online promotion of that project, we use Google search result as our control variable, which is defined as the number of web pages returned if you Google search the name of that project at the time of the tweet. The more web pages returned, the more social media online discussion the project received. Our final model combines a time series analysis, a control group design, and an explicit control of some confounding variables. Again, the estimated causal effect of the tweet is calculated by first calculate the difference between the number of stars received before and after the tweet, and we calculated the difference of that difference between the treatment group and the control group, and we subtract that by the estimated effect of other confounding events that we explicitly controlled for. This model is best known as difference in differences model, or diff-in-diff for short. It is relatively novel and new in software engineering communities, but it has been widely used in fields like econometrics, political science, and social science for a course of 20 years. And recently, its value to infer causal relationship with natural experiment has been recognized and awarded the Nobel Prize of Economics in the year of 2021. Limited by time, we can't go through all the details of our study, but we can provide a high-level overview of the data set and some important steps in the research. Overall, we conduct a large-scale mixed method research, and we look at a set of over 2,000 open source projects hosted on GitHub, and we get all the tweets that are containing a link to those projects' GitHub page within a period of 6 months. Overall, there were 40,000 such tweets. There were several important steps that made this study possible. First, we find that tweet promotion for OSS project is very bursty. It's hard for us to isolate the effect of a single tweet when it was posted simultaneously with others together. What we did instead is we merged tweets into bursts based on the similarity of time posted. And the burst is the smallest unit of analysis in our study. We also build our research on a previous paper published by me and several other members in the group, that for each open source developer, we find their Twitter and GitHub account. By doing so, we can identify the relationship and the connection between the tweet author and the project it tweets about. And we can look into whether this factor associates with the size of the tweet promotion effect. In addition to the quantitative study, we also conduct qualitative analysis over a set of tweets by looking into the content of the tweet. And we use that to infer the relationship between the tweet author and the attracted developers. For all the details on data collection and the important step of our analysis, please read our paper. So what did we find in the study? First, we find that tweets help attract both stars and new developers. The effect is strong on star, but marginal on new developers. After controlling for all other variables we discussed before, on average, we find every tweet burst help attract 7% more stars in a period shortly after compared to the period before. It corresponds to 1.2 more stars added for every tweet burst. In contrast, tweet bursts help attract 2% more developers, and it corresponds to 1 new developer attracted for every 250 tweet bursts posted. Second, we find a series of factors associated with the size of tweet promotion impact, like the tweet author's connection to the project it tweets about, or the past tweet communication between the tweet author and the attracted developer, as well as the content of the tweet. All matters to the tweet promotion effect. Using those two tweets as an example, the left one provides a description of GitHub project feature, and the right one provides a description of a specific problem to be worked on, and it contains a link to the GitHub issue page of that problem. We find the tweets like the one shown on the right, where it describes a specific problem instead of the general feature of the project, is more influential to attract new developers, and there is no statistical difference between their ability to attract stars. Please read our paper for more details and discussions on these specific factors and many other factors we analyzed that affect the promotion effect of tweets. So what are the implications of our study? First, we find tweet promotion can be a double-edged sword. On the one hand, we find tweet promotion is an effective tool to attract new developers as well as new stars. But on the other hand, research have warned that an increased level of community attention usually comes together with an increased level of feature requests and issue posts. And it can add burden to the developer teams, and developers can be overwhelmed by this increased level of requests, especially when there is no proportional increase in the number of developers. And this is exactly what we see on Twitter promotion, that it has strong impact on project popularity and community attention, but have relatively less impact on attracting new developers. Developers should be aware of that risk before they decide to tweet and promote their project on Twitter. Second, we find a series of factors associated with the impact of tweet, which provide practical guidance for OSS developers to better promote their project. Next, we find maintaining social connections on Twitter and having a Twitter communication for OSS project can help the project attract more developers. We are only scratching the surface in that area, and we call upon more research to study the value of Twitter communication and Twitter community for the sustainability and success of OSS projects. Lastly, the overall open source community is a complicated ecosystem, and there is much more beyond developer activities on the code hosting platforms like GitHub, which is the major focus of research in the past 15 years. Our study is a part of a large collective effort to use this large-scale social media communication, human interaction data on platforms like Twitter, Hacker News, and Slack, and many others. And we adopt those more sophisticated, powerful causal and computation approaches to make connection between the activities, developer activities on those platforms, and the success and the sustainability of open source projects and communities. We believe this is a promising direction, and we hope more researchers can join together in this collective effort. To summarize, our study adopts a powerful causal inference model diff in diff, and we conduct a large-scale mixed method study over 2,000 open source projects and 40,000 tweets. We find that tweets can help attract both stars and developers, but its effect size varies on different outcomes. We provide a series of implications to both the open source researchers and also to developers working on open source softwares. The paper and replication package of this study are publicly available online. And again, I'm Hongbo Fang. I'm a PhD student from Carnegie Mellon University. Please reach out to me via Twitter or email if you have any questions or you want to discuss more about this paper. And thank you for listening to my talk.